Objective 5. Check a set of data for outliers. When analyzing data, we must check for extreme observations called outliers. Outliers can occur by chance, because of errors in the measurement of a variable during data entry or from errors in sampling. Outliers aren't always due to error or chance. Sometimes extreme observations are common within a population. For example, suppose we wanted to estimate the mean price of a European car. We might take a random sample of size 5 from the population of all European cars. If our sample included a Ferrari F430 Spider, approximately $175,000, it probably would be an outlier because this car costs much more than a typical European car. The value of this car would be considered unusual because it is not a typical value from the data set. Caution: how do outliers affect the mean and the standard deviation? Outliers distort both the mean and standard deviation because neither is resistant. Because these measures often form the basis for statistical inference, any conclusions drawn from a set of data that contain outliers can be flawed. Now, checking for outliers by using quartiles. Step 1, you determine the first and third quartiles of the data. Step 2, you're going to compute the inner quartile range. And step 3, you're going to determine the fences. Fences serve as cutoff points for determining outliers. You have the lower fence, which is quartile 1 minus 1.5 times the inner quartile range. And then you have the upper fence, which is equal to quartile 3 plus 1.5 times the inner quartile range. Now, if a data value is less than the lower fence or greater than the upper fence, it is considered an outlier. So, for example, checking out for outliers. Check the data in the table below on collision coverage claims for outliers. So we're going to follow the steps for checking for outliers. Any data value that is less than the lower fence or greater than the upper fence will be considered an outlier. So for step 1, the quartiles found in the previous example are, we have quartile 1, which is 735, and quartile 3, which is 4,668. Okay, and then we also determined that the inner quartile range is taking these two values, subtracting them to get 3,933. So we have the inner quartile range, and we have quartile 1 and quartile 2. Now, quartile 3. So now what we want to do is we want to find the lower fence. So the lower fence is taking quartile 1, which is 735, and then we're going to subtract 1.5 times the inner quartile range. So when we take 735 minus 1.5 times 3,933, we get negative 5,164.5. Let's just confirm that on our calculator. Okay, we're going to take 735 minus 1.5 times the inner quartile range of 3,933, and that gives us negative 5,164.5. Okay, now we're going to find the upper fence, and the upper fence is taking quartile 3, which is 4,668, and then we're going to add 1.4 times the inner quartile range, which is 3,933. So let's go ahead and do that on our calculator. 4,668 minus 1.5 times inner quartile range of 3,933, and we get, oh, sorry, I made that a plus. So, I'm sorry, that was a minus, so let's change that to a plus so we get the correct result. And we get 10,567.5. Okay, so what does that mean? Okay, I'm going to draw a picture so you can see visually what this means. Okay, so what we have is we have a lower fence of our data value and our upper fence. Okay, let me go ahead and rewrite that again, upper fence. So here is our lower fence, and then here's our upper fence. Now our lower fence is the value of negative 5,164.5. And then our upper fence is going to be the value of 10,567.5. Okay, now anything outside of this, okay, so I'm going to put this in red. So anything outside here or anything outside here would be considered an outlier. So anything outside here would be an outlier, meaning anything that's less than that number, or anything over here would also be considered an outlier. So we need to look at our data set. Now, are there any numbers that are less than negative 5,164.5? Well, if we look at any of these numbers, we do not have any numbers that's less than that. Okay? Then we need to determine, are there any numbers greater than 10,567.5? Well, the largest number is 21,147. So let's go ahead and take a look at that. So we have this number, which is larger. Are there any other numbers that's outside of that? Okay, so we just have one. So there are no observations below the lower fence. However, there is an observation above the upper fence, and we can say that the claim of 21,147 is an outlier. And in this case, we would then go back up here, and what do we say up here? We said that the value of this car would be considered unusual because it is not typical value from the data set. So we also need to say that this represents an outlier, but it also represents an unusual amount. So it's also considered unusual.